Very good morning, class. Yesterday, I have completed a very important force, the fundamental force that we can find in nature, that was gravitational force. Yeah, we have seen how many theories are given to explain the G force. First, the theory given by the Newton. Then Einstein gave the new theory, theory of relativity. Then the modern theory is somehow different, right? It says that how the two particles can interact with each other by the exchange of a particle known as graviton. Today we will discuss next important force. If I'm saying the next important force, it is not like one force is important or other force is less important. No, each and every force is equally important to survive the universe. Okay, I will explain you how, even if any one of these four forces get finished, our universe can't survive. Okay, so we'll talk about it later. The next force I'm going to talk about is electromagnetic forces. Here we are using term electro and magnetic because basically electrical field and magnetic field, they both are, we can say, they are same things and they are just the two different manifestations. Okay, we can create electrical field with the help of magnetic field and vice versa. Well, that is why I have written here electromagnetic force. Neither electrical force nor the magnetic force. We have combined these forces. Okay, so what is the electromagnetic force? Like in the gravitation, the G force was created due to the mass of the body. If two bodies have masses, then they will attract each other with some force. Similarly, this force, electromagnetic forces, is due to the charge present inside the body, right? Like in that G force, we have mass. In this case, we have charge. Okay, so a very famous scientist, Coulomb, gave an expression to find the attractive force or repulsive force between the given two pair of the charges. It says, suppose we have two charges here. Let's say this is Q1 and let's say this is Q2, and they are separated by a distance r, right? Then the force of attraction between attraction or repulsion, it depends upon the nature of the charges. First, it is directly proportional to the product of their masses and second, it is inversely proportional to the square of the distance between them. Now you can see that if you remember my yesterday's video, that G force was quite same. G force was that F is proportional to the product of masses and inversely proportional to R square. So you can see that it is somehow same, right? It is, we only different, the different is that in this case we were using masses, in this case we were using charges. So when you combine these two laws, you'll get F proportional to Q1 Q2 upon R square, like in this case, and after that we get a constant K and Q1 Q2 upon R square. Okay, like here the value of constant was 6.6 into 10 to the power minus 11. Here the value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. So right, so this is the magnitude of electromagnetic force acting between two bodies, right? And see, the very important property, this force can exist only when the two bodies have some charges. This force can be repulsive and can be attractive. So this is the difference between the G force and the electromagnetic force. G force can be attractive only. It can't be repulsive unless we discover the anti-gravity, right? It's a new field of discovery. I'm not talking about that. So if we have a mass, positive matter, then it always attract one body to the other body. It can't repel. Although I'm not take so much time about this topic, that although scientists have, we can say, they have a hypothesis that there is a term known as dark energy, which create an anti-gravity effect. Like in this effect, gravity, body attract each other. In that effect, dark energy, the body repel each other, and that is why our universe is continuously expanding. Right, so let's forget about that. So here, like in this case, with the charges can be positive or negative, and depending upon the nature of the charges, the force can be repulsive or attractive. If both the charges are of same nature, that is positive positive or negative negative, then they will repel each other. And if charges are alike, then they will attract each other, right? So this is one property of this force. Second property, again, it is a central force. I've explained to you yesterday what is central force. It acts between the center of the two bodies. It not act between the surface of the body, right? It acts center to center. Second, you can see that this force is also follow the inverse square law upon r square, right? So these are some important point of electromagnetic force. Now I told you that there are some modern theory in G force also. Similarly, in this case, modern theory says that the force of attraction between these charges is due to the interchange of a particle known as photon, right? I'm not again going into the deep because it is not in your syllabus. Just I want to give you a gist about it, that according to modern theory, that there are some called the interchange of a particle known as photon. Photons kind of energy which have very less mass and it has only energy. Most of it is form of energy, right? So due to interchange of that particle photon, this force is created, right? Okay, this force is much stronger than the G force. I will compare these forces after when we have complete all these forces. Then I will compare the we can say magnitude of these forces, that how much strong the G force is or how much strong is the electromagnetic and other two forces. Okay, so let us talk about the another force that found in nature. The next force that we have found in nature is strong nuclear force. I found this force most mysterious because it is the strongest force we have found in nature, and we don't have much information about it. Again, I said we are in the this stage of discovering new phenomena. Okay, now what is strong nuclear force and how it is different from the gravitation and the electromagnetic forces? To understand this force, let's take an atom. Let's say this is an atom, right? Inside the atom, we have a nucleus, right? This is the atom, and these are the electrons revolving around it, and this is the nucleus. Now, if we zoom into the nucleus, right? ये मैंने इसको zoom करके दिखा दिया, right? So when you peek into the nucleus, you find that we have two more particles inside the nucleus. First, we have protons. Inside the nucleus, we have protons and neutrons. Alright, so now you can see that this is a nucleus, which is in which we have neutrons and protons. You have studied in the class 10th that neutron is a neutral particle. Neutron has no charge. This is neutron. Charge on neutron is 0, right? But yeah, mass have some mass on it. Mass of neutron is approximately 1.6 into 10 to the power minus 27 kg. This is the mass of the neutron. If we talk about the proton, then the charge on proton is 1.6 into 10 to the power minus 19 coulomb, and mass approximately equals to mass of neutron. The masses, they both are approximately equal. Neutron is a bit heavier, but it is not that heavier that we distinguish between them, right? It is approximately they have equal masses. Now, I have just explained you in electromagnetic forces that if the charges are of same nature, that is positive or negative, then they start repulsing each other, right? In the nucleus, we have, you can see that, neutron, no problem, because they don't have charge, so they will not create any repulsive force between them. But proton, they both are positive charge. And if they have positive charge, so they must repel each other with enormous force, right? But after that force, these proton resides inside the nucleus. They do not come out of the nucleus so that the nucleus, we can say, it becomes unstable. No, it remain inside the nucleus. Now, obviously, there must be some attractive force between the proton, which is more stronger than this repulsive force. That is why proton is not repulsing each other and going far away from each other, right? See, there must be some gravitational force also in between the proton. But as I told you, gravitation force is the weakest force, right? It is the weakest force, and this gravitation force, the gravitation attraction between these proton cannot overcome with the repulsive force of the electromagnetic force. So there must be some another kind of force that is attracting in nature, is acting between proton, and that force is known as strong nuclear force. So due to this force, and it is not like that this force only acts between the proton. This force acts between proton, neutron, and proton. That means the proton is attracting the other proton is attracting another neutron, and neutron attracting another neutron. So they all attract each other so that they will remain stable inside the nucleus. So this is your strong nuclear force. Why it is, I said it is a mysterious force? Because first thing, this force, unlike the electromagnetic and the that G force, it doesn't follow the inverse square law. We don't have certain kind of formula. Like in the G force we have a formula, in the electromagnetic force we have a formula. In this case we don't have a certain formula, and it is also not the central force, right? Reason of the force acting between them is basically, again, that I told you, that whenever two bodies repel or attract each other, then there must be some interchange of the particles, right? Proton and neutron are not the fundamental particle of the nature. They can be break into the quarks, right? Proton and neutrons can be break into the form of quarks, right? And inside the proton and neutron, these are quarks, and they attract each other, right? Suppose we have we have proton here, and we have neutron here. So inside the proton we have 3 quarks, inside neutron we have 3 quarks. They attract each other, and how they attract each other? They interchange some particle between them, which is known as meson. Like in the gravity, there is a graviton. In electromagnetic we have photon, and in the nuclear forces we have meson. See, all these, I'm teaching you, these all things are in your book. If you are thinking, sir, kahan chale gaye proton, neutron or quarks, no, it is also, all the things are given in your notebook, in your textbook. You can check, right? I'm just telling you the gist, how these forces can act. So this is how the force, nuclear force act. So this is your strong nuclear force. This is the strongest force in the nature. Now we are only left with one force, which is known as weak nuclear force. And this is the strong nuclear force. And then next we have the weak nuclear force. I will cover that weak nuclear force in the next video, and that will be the last video on this chapter that I'll give you tomorrow. Okay, and after that we'll come to the error analysis and damage analysis from the next chapter. Okay, one more thing, that this force can act only with the short ranges, right? Only to the 10 to the power, we can say that if we talk about the range of this range is too small. The range is about 10 to the power minus 15 meter to 10 to the power minus 14 meter. The diameter of the nucleus is the order of 10 to the power minus 15 meter. So if these two particles go away more than 10 to the power minus 14 meter, then this force cease to exist. Okay, this force completely vanished, and then there will be only repulsive force of the electromagnetic in nature, and there can be attractive force of gravitation, but this force will not act if the particle go away more than 10 to the power minus 14 meter. Okay, so I will cover, as I told you, that I will cover the next and the last force, fundamental force in nature, in the next video. And I also I'll tell you about how important are these forces, right? Even if we don't have one force, we can't survive in the universe. Our whole universe will split, right? It will torn apart. Okay, so please go through your textbook and read this. What are the important points, right? How this force acts. Okay, so thank you so much.